Okay, I'd like to introduce you to the 4-quadrant dynamometer power supply. The number is 89600-2A. Now, when you use this dynamometer, you make sure that the selector switch is on dynamometer. You've got an LCD display here which gives you speed, torque, power and status, which includes the mode that you selected and whether it started or stopped. There's a function button here which changes the mode that this operates in, and also you've got a command dial which changes either speed or torque as dependent on the function you've selected here. If you inadvertently hook up, say, the power supply to here and switch it on, you'll end up tripping the main supply for the lab. So you need to have this hooked up here. This is a regular power lead and switched on, and you notice we've got torque and return and speed hooked up to the data acquisition system. I have found that the speed shown in the data acquisition system is double this. I'm not really sure why, so just be aware of that. This is the true measurement of speed and this is the true measurement of torque here. So I'm just going to zoom in on this display here while I go through just a couple of the functions that are important to know. I'll just do the old manual zoom because I really want you to see the text at the bottom here. So just out of interest, I've got a synchronous motor hooked up to drive this load, but I'm only going to be running it with excitation off just to give it some display readings on here. So you may notice that I've got on here CWCS prime mover brake. So what this means is clockwise, constant speed, prime mover brake. So constant speed means if the motor tries to drive this dyno faster than the preset speed, the dyno will act as a brake and slow the motor down. If the motor is acting as a load, the dyno will act as a prime mover to bring the speed up to the setting here. So I'll just illustrate that speed control now. I've actually got the motor itself turned off, and if I press start, you can see it's jumped right away to a preset here. If I change the style here down to 0, right, and that's something to be aware of too, is that when you start this, make sure that it's fully counterclockwise unless the lab manual specifies otherwise. So you can rotate that dial up there. And I'd encourage you to test out the dyno separately to everything else just to familiarise yourself with the functions. Notice these values are negative. The negative sign means that it's delivering torque and power in this direction from here to the motor. If they were positive, it would mean that it's acting as a load and it's receiving driving power from the motor. By the way, this value for torque and power includes windage and friction losses. So you can see that I've got pretty precise control over it. It's a multiple turn pot. Okay. Now bear in mind the rated speed for all of these machines is 1500 RPM. So if I was using this as a prime mover, now there's a bit of overshoot. Notice that as I dial it, it keeps going a bit higher. Okay, I'll just stop that now, wind that back down again and press stop. Now I'm going to start up the motor itself and I'll show you another function here. Alright, so I'm running the motor. I haven't started this yet, so there's nothing on the display. Now I'll press start. Now notice that it's dropping it down to 0. It's actually forcing it down to 0. Very hard on both the devices to do something like that. So I wouldn't really recommend doing that to the motor, not forcing it down to 1500 RPM. Now, as an induction motor, it's comfortable at around 1400 RPM. So that's around the induction motor speed. And as a synchronous motor, it's closer to 1500 RPM. So if I wind it back to around 1400, you can see the power level changing. It's going up. It might be actually 1460. So I can actually adjust that to close to 0. There you go. So that's synchronous speed. Now what I want to show you, as soon as I press stop, the speed jumps to its natural speed. Okay. I'll make now the next part is, if I press function, you've got a few other functions here. This is counterclockwise, constant speed, positive, constant torque, prime mover brake. So that's in the positive quadrant, not as well in the negative quadrant. Negative, constant torque. 2-quadrant constant torque brake. This is the one we want. If I go further, it goes to clockwise prime mover brake again. So we'll keep going through. So 2-quadrant constant torque brake. Now this is purely as a brake. So I can wind this right up. I can press start. It's not acting as a prime mover. It's only acting as a brake. So I'll turn that back down to 0. Start our motor up. Now I'll talk about motors later. So you can see now, even though it's started and it's showing the speed and the torque and the power there. So they're all positive, means that's how much torque is being delivered to the dyno, that's how much mechanical power is being delivered to the dyno, and that's the speed. Now using it as a brake, I simply dial that knob up there. And there's a bit of a delay. Eventually you should see the torque increase. Here we go there. And you can see the load increasing there. If I press stop again, that load all drops off. Start, the load drops on. So that's the start-stop function there. So to recap, there's only 2 functions that you will use here. You will use the 2-quadrant constant torque brake to act as for loading the motor. When you want to run the motor as a generator, you need to use the sorry, I've gone too fast now. You need to use the constant speed prime mover brake. Now that will actually fix to a constant speed. You can also go for the constant torque option here as well. So this is constant torque. So you can adjust the speed or you can adjust the torque as well. So there's 2 options there. I hope that helps. I think I should just demonstrate the constant torque brake a little bit. Constant torque prime mover. Okay. So I start the motor up. Stop. Just turn that down to 0. Start. You can see there, it's delivering torque back to motor. So in reality, I think the best ones to use is your 2-quadrant constant torque brake and your clockwise constant speed prime mover brake. Those are the 2 functions you need.